Hello everyone. So let's start today class. In the last class, we will discuss about the factor on which the resistance of a conductor depends. Okay. So today we will discuss about combination of resistors. Combination of resistors. In the last class, we already discussed about resistance. Resistance is what? Resistance is the opposition offered by electric current when it flow inside the conductor. So today, in today class, we will discuss how we combine these resistors. How we combine these resistors in an electric circuit, right? So basically, there are two ways. Basically, there are two ways to combine a resistor in an electric circuit. One is series combination, one is series combination, and other is parallel combination. First we discuss about series combination, after that we will go to parallel combination of resistor. So let's start series combination of resistors. To understand series combination, first we will take a resistors. First we will take a resistors. This is a resistor which have two ends. This is first end of the resistor and this is second end of the resistor. Now we have to combine these resistor in series. So we take another resistor. So here basically we take three resistors whose resistances are R1, R2 and R3. Okay. Now these resistors are connected end to end because every resistor has two ends, first end and second end. Now see, second end of first resistor is connected to first end of second resistor. Like the same way, the second end of second resistor is connected to first end of third resistors. Okay, so when these resistors are connected end to end, when these resistors are connected end to end, this type of combination is called your series combination of resistors. This type of combination is called your series combination of resistors. So let's write the definition now. When the resistors are connected end to end, this type of combination is called your series combination. Okay, now draw an circuit diagram of this series combination. So already we take three resistors whose resistance are R1, R2 and R3. Now connect these three resistors with a battery. Connect these three resistors with a battery whose potential difference is equal to V, and insert a switch which is represented by K and connect a ammeter who measure the electric current. Okay, so from the battery there is electric current I. There is electric current I. Now when you see that electric current pass through that resistors, when we see that I current pass through this resistors R1, then it is opposed. This electric current will be opposed by this resistors. Due to the opposition of this current, there will be a change in potential difference. There will be a change in potential difference. Like in the same way, when this current enter in the second resistor, then again its opposition and again potential difference is changed. Again potential difference is changed. And so on, when this current pass through this resistor, again potential difference will be changed, is V3. Okay, then I current will pass through this way. Okay, now you will see that in the circuit diagram that total potential difference of this circuit diagram is equal to V. But when electric current pass through the battery, due to the oppositions, their potential difference will be changed into V1, V2 and V3. V1, V2 and V3. Now, if we see that total potential difference, V is equal to what? V is equal to V1 plus V2 plus V3. Right? So, let's draw the formula of series combination of resistors mathematically now. Here, see in the diagram that total potential difference V, total potential difference is given by V. The total potential difference, I represent this potential difference by P or D. The total potential difference is given by V is equal to V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. Assume that this is equation number 1. Okay, fine. Now, let's see. If we apply Ohm's law here, according to Ohm's law, V is equal to what? V is equal to IR. We already discussed about that V is equal to IR according to Ohm's law. Now, the question is, we also find out the value of V1, V2 and V3. Okay. So, to find the potential V1 is equal to what? Let's see in the diagram. Where is V1? That one. V1. So, from V1, you will see that total current is passed through the V1 is I and the resistance is R1. So, V1 is equal to what? I R1. Similarly, V2 is equal to what? V2 is where? There. V2 is equal to I R2. V2 is equal to I R2. And similarly, V3 is equal to I R3. Right? Now, putting the value of this V, V1, V2 and V3 in equation 1. Now, so, putting the values of V, V1, V2 and V3 in equation 1. What will we get? We get that V is replaced by IR is equal to V1 is equal to I R1, V2 plus V2 is equal to I R2 plus V3 is equal to what? I R3. Clear? Okay. So now you will see that I is same in everywhere. So we will take common. I is taken common. What will we get? R1 plus R2 plus R3. In the left hand side is IR. I and I is equal on both sides. So I is cancelled. What will we get? we get R is equal to R1 plus R2 plus R3. So this is the your final formula to find series combination of resistors. One thing that we observe in series combination is what we see in the circuit diagram, that the value of I will remain same everywhere in the circuit, but the value of potential difference will be changed. In series combination, the value of potential difference will be changed. So this is important point. You have to note that. Note, in series combination, in series combinations, I will remain same, but V will be changed. V will be changed. So that's why I will remain same and V will change. That's why ammeter is always connected in series. In the first lecture, we will discuss about electric current. I'm telling you that electric current is measured by ammeter and always connected in series. But I'm telling you that later I will tell you why this ammeter is connected in series. So here is the reason that why ammeter is connected in series, because in series combination I will remain same but V change, yani potential difference will be changed. So this is our series combination of resistors. Series combination of resistors. Okay. So next we will discuss about parallel combination of resistors. Parallel combination of resistors. So let's start parallel combination of resistors. Now, parallel combination of resistors. Parallel combinations. In parallel combination, we again take three resistors. We again take three resistors. Sorry. We again take three resistors parallel to each other. Parallel to each other. Okay, whose resistances are given by R1, R2 and R3. Now, see, first end of all these three resistors are connected to a point. First end of all these resistors are connected to a point. Okay, and this point is called a junction. What is junction? Where two or more than two paths where two and more than 2 points separates. Okay, so again first end of all these three resistors are connected to a point which is called junction. In the same way, second end of all these three resistors are also connected to a point. Are also connected to a point. Okay. Now you will see that we take three resistors which is parallel to each other. Now combine these three resistors to a battery. How do we combine? That first end of all these resistors are connected to the positive terminal of battery. What we do? First end of all these three resistors are connected to positive terminal of battery. Okay. Now insert a switch and see, second end of all these resistors, are connected to the negative terminal of battery. Second end of all these resistors are connected to negative terminal of the battery. Okay, so this type of combination is called your parallel combination. Now the battery has potential difference V and electric current is flowing I. Okay, so you will see that I current is flowing through this circuit, but when I is passed through the point P, then this I will be divided in the three way. This I has three path, which is in this way. Then I is divided in I1, I2 and I3. Okay. In a similar way, I1, I2 and I3. But again, after passing through a point Q, you will see that total current is equal to I. Okay. So this is our circuit diagram of parallel combination of resistors. So this is the circuit diagram. Now first we will write the definition of this combination, then we will prove it mathematically. Okay. So how we write the definition? What we observe from the diagram? We see that first end of all these resistors are connected to the positive terminal of battery, and second end of all these resistors are connected to the negative end of the battery. So this type of combination is called your parallel combination of resistors. So let's write the definition. When first end of all the resistors are connected to positive terminal of battery, and second ends of all resistors are connected to negative terminal of battery, then this type of combination is called your parallel combination of resistors. Okay, when first end of all the resistors are connected to positive terminal of battery, and second end of all the resistors are connected to negative terminal of the battery. This type of combination is called your parallel combination of resistors. Okay, now we will prove it mathematically. Before proving it mathematically, let's see the diagram. In the circuit diagram, what you will say that I will divide into three parts, but the potential difference will remain same. Okay. Here we see that total electric current, the total electric current is given by I is equal to I1 plus I2 plus I3, and assume that this is equation number 1. Okay. What will we see? We see that the total current flowing through this electric circuit is equal to I, and this I will be divided through the resistors R1, R2 and R3 in I1, I2 and I3. Okay. So again, when electric current leave from the resistors, then this is also equal to I. Yani sum of these I1, I2, I3 is always equal to I. Okay. Now again we apply Ohm's law. Again we apply Ohm's law according to Ohm's law. According to Ohm's law. According to Ohm's law, V is equal to what? V is equal to what? I R. If we find the value of I, then I will be equal to V by R. I will be equal to V by R. In the same way, we will find the value of I1, I2 and I3. So, I1 is equal to what? I1 is equal to what? I1 is there. So, let's say I1 is equal to what? The potential difference will be remain same for every resistor and resistances are changes. So R1, R2 and R3. So I1 is equal to potential difference V, resistance R1. So I1 is equal to V by R1. Similarly, I2 is equal to V by R2 and similarly I3 is equal to V by R3. Okay. So I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Clear? Now we will get the values of I1, I2 and I3. Now what we have to do? We have to put this value of I1, I2, and I3 in equation 1. In equation 1. So let's put the values of electric current. So put the value of I in equation 1. I is equal to what? I is equal to V by R. V by R is equal to I1. I1 is where? V by R1. V by R1. Okay. So similar way plus I2. I2 is equal to V by R2. V by R2 plus I3 is equal to V by R3. So you will see in this equation that V will be same everywhere. So we take common and what will we get? 1 by R1 plus 1 by R2 plus 1 by R3. Okay. And this is equal to V by R. V and V both side equal, so cancel with each other. What will we get? We get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is your final formula to find the parallel combination of resistors. To find the parallel combination of resistors. Clear? Okay. So important point is what here? Important point is that V will remain same in parallel combination, but I will be changed. That's why voltmeter is always connected in parallel. That's why voltmeter is always connected in parallel, not in parallel combination. In parallel combinations, V will remain same and I will be changed. Okay. So this is our topic, combination of resistors.